Good morning, everyone. Today, I am discussing to you the advanced sorting algorithm in Java programming. So, what is this so-called sorting algorithm? A sorting algorithm is an algorithm that puts elements of a list in a certain order. The most used orders are numerical order and lexicographical order. Efficient sorting is important for optimizing the use of other algorithms such as search and merge algorithms, which require input data to be in sorted lists. It is also often useful for canonicalizing data and for producing human-readable output. Bubble sort. It is also referred to as sinking sort. Is a simple sorting algorithm that works by repeatedly stepping through the list to be sorted, comparing each pair of adjacent items and swapping them if they are in the wrong order. The pass through the list is repeated until no swaps are needed, which indicates that the list is sorted. The algorithm gets its name from the way smaller elements, or what we call bubble, to the top of the list. Because it only uses comparisons to operate on elements, it is a comparison sort. Although the algorithm is simple, most of the other sorting algorithms are more efficient for large lists. So, this is the sample of the bubble sort. As we notice, the five elements above, it is unsorted. So, what we are going to do is to sort them all. Okay? So, we have to sort the first two elements. So, 5, 1 is unsorted. What we are going to do is to sort the 2. So, yung 1 mapupunta sa left side at yung 5 mapupunta sa right side. So, as we observe, 1 at 5 ay sorted na po siya. At saka yung 5 at 12 sorted na rin. So, yung yung 12 at -5 is unsorted. So, what we are going to do is to sort the two elements, 12 and -5. So, yung -5 mapupunta sa left side at yung 2 is mapupunta sa right side. As we observe, -5 and 12 is sorted. So, uh, pupunta na naman tayo sa dalawang numbers. Titingnan natin kung sorted ba siya or not. So, yung 12 at 16 is sorted. So, okay na yon. So, kapag titingnan natin yung 5 elements, hindi pa siya okay. Hindi pa siya sorted lahat. So, we observe the numbers. So, 1 at 5 is sorted na yan. And then yung 5 and -5 is unsorted. What we are going to do is to sort the two elements, the 5 and -5. So yung 5 mapupunta sa right side at yung -5 ay mapupunta sa left side. So, titingnan natin, i-check natin. Yung 1 tsaka -5, hindi pa siya sorted. Yung -5 and 5, sorted na siya. Yun na yun. Sorted na siya. Yung 5 and 12, sorted na siya. Then yung 12 and 16, sorted na siya. So, what we are going to do is to sort the unsorted two elements, 1 and -5. Yung -5, mapupunta sa left side at yung 1 is mapupunta sa right side. So, ito na yung magiging resulta niya. -5 and 1 is sorted, 1 and 5 is sorted, 5 and 12 is sorted, 12 and 16 is sorted. So, kapag i-check natin, okay na siya. So, ito yung output ng unsorted elements kanina yung nasa taas. So, ito na yon yung output niya. Sorted na siya. -5, 1, 5, 12, and 16. Sorted. Ito yung example ng bubble sort. Titingnan natin, yung 5 elements sa taas is unsorted. So, maraming process pa ang gagawin bago natin ma-cough up ang final output ng unsorted. Ito na siya. Simula unsorted, sorted na siya dito sa baba. Bubble sort has worst case and average complexity both 0 and 2, where n is the number of items being sorted. There exist many sorting algorithms with substantially better worst case or average complexity of 0 and log n. Even other 0 and 2 sorting algorithms, such as insertion sort, tend to have better performance than bubble sort. Therefore, bubble sort is not a practical sorting algorithm when n is large. Performance of bubble sort over an already sorted list, best case, is 0n. So, this is the sample program in Java of the bubble sort. So, ito po yung halimbawa ng Java programming ng bubble sort. So, kung iraran po natin yan, ito po ang magiging resulta. Ito po yung magiging output niya. From unsorted elements to sorted elements. So, dito maraming process ang pagdadaanan ng program bago masort yung elements. The selection sort. It is a combination of searching and sorting. During each pass, the unsorted element with the smallest or largest value is moved to its proper position in the array. The number of times the sort passes through the array is 1 less than the number of items in the array. In the selection sort, the inner loop finds the next smallest or largest value, and the outer loop places that value into its proper location. So, ito na po yung halimbawa ng selection sort. Selection sort. So, as we notice the elements above, it is unsorted. So, marami na namang tayong process na gagawin bago natin makuha ang final output or sorted elements. So, we have to choose two elements, two smallest or largest elements that is not sorted or unsorted. So, as we observe, mas malaki yung 5 tsaka 1. Pero yung sinabi kanina doon sa selection sort, um, lowest. So, since yung 1 at 12 is sorted naman siya, so what we are looking for there is the smallest number that is not unsorted. So, yung 1 at 12 is sorted na yan. Kahit maliit yung 1 tsaka 5, pero yung kung pagmamasdan mo natin yung mga numbers, yung 5 tsaka negative 5 is unsorted po siya talaga. Pero yung 1 at 12 is sorted. So, we select 5 and negative 5 kasi hindi po siya sorted. So, 5 and negative 5. Tapos yung 16 hindi niya nakasort. Pero, mas malaki yan kaysa dito sa negative 5 and 5. Yung 2 at saka 12 sorted, 12 tsaka 14 is sorted. So, ang magsaswap lang na elements ay yung 5 at saka negative 5. So, ganito ang mangyayari. Yung negative 5 ay mapupunta sa left side, sa unahan, at yung 5 mapupunta dito sa right side. So, nag-swap lang sila, nagpalit lang silang dalawa. So, i-check ulit natin yung numbers. Negative 5 and 1 sorted. 1 and 12 is sorted. 5 and 16 is sorted. 16 and 2 is unsorted. 2 and 12 is sorted. 12 and 14 is sorted. So, titingnan pa natin yung lowest number na hindi sort. So, we have to choose, we choose 12 and 2. 12 and 2. Kasi titingnan natin kung ano yung susunod sa 1. So, 2. Hindi naman pwedeng 5 kasi mas maliit yung 2 kaysa sa 5. So, ang magswaswap, ang magkakapalit ng pwesto ay yung 2 at saka 12. So, negative 5 and 1 is sorted. This number is not sorted. So, ano yung susunod sa 1? So, yung 2. So, magkakapalit yung 2 at saka 12. So, ang mangyayari, ang 2 ang mapupunta sa left side at yung 12 mapupunta sa right side. So, negative 5 and 1, sorted. 1 and 2 is sorted. Kasi ang kasunod ng 1 is 2, so sorted na siya. Kasunod ng 2 is 5, so sorted na rin yan. So, ang susunod na ating gagawin, na we look to elements that is unsorted but lowest. So, magkapareho yan, katabi sila, okay yan. Magkapareho silang number. Pero itong 16 and 12 is unsorted. So, ano yung susunod sa 5? Ang susunod sa 5 is yung 12. Kasi yung 12 is smallest element than 14. So, ganito ang mangyayari. Yung 12 and 16 ay magsasapyang dalawa. Yung 12 is mapupunta sa left side and yung 16 is mapupunta sa right side. Magsaswap lang sila, magkakapalit lang sila ng pwesto. So, negative 5 and 1 is sorted, 1 and 2 is sorted, 2 and 5 is sorted, 5 and 12 is sorted, 12 and 16 sorted na yan. Pero meron pang dalawang element na hindi sorted. So, what you are going to do is to swap the two numbers, 12 and 16. So, yung 12 mapupunta sa right side, makapareho sila, okay lang yan. Na yung 16 is mapupunta sa right side. So, as we observe, as we notice, negative 5 and 1 is sorted, 1 and 2 is sorted, 2 and 5 is sorted, 5, 12 is sorted, 12 and 3 is equal, okay lang yan, 12 and 16 is sorted. Pero ano yung dapat na susunod sa 12? Is yung 14. So yung 16 and 14 magsaswap na naman yung dalawa. At ito na yung magiging final output niya. Negative 5, 1 sorted, 1 and 2 is sorted, 2 and 5 is sorted, 5 and 12 is sorted. So magkapareho yan, 12 and 12, okay lang yan. 12 and 14 is sorted, and 14 and 16 is sorted. So as we notice, nakuha na natin yung final output ng unsorted elements above. So, dadaan tayo sa maraming proseso bago natin makuha ang sorted elements. Yan ang halimbawa ng selection sort. You have to choose two elements, lowest two elements that is not sorted or unsorted. Selection sort is not difficult to analyze. So, it means mahirap talaga compared to other sorting algorithms since none of the loops depend on the data in the array. Selecting the lowest element requires scanning all n elements. So, syempre, hindi ganun kadali ang mag-sort ng selection sort. Pahirapan ang pagsosort sa selection sort. Selecting the lowest element requires scanning all n elements. This takes n-1 comparisons and then swapping it into the first position. Finding the next lowest element requires scanning the remaining n-1 elements and so on. For n-1 plus n-2 and so on and so forth. Each of these scans requires one swap for n-1 elements. So, this is the sample program of the selection sort. So, if you run this program, it will show the output 2, 7, 10, 34, 42, 56, 67, and 88, which are sorted. insertion